All right, so in a problem like 18, it's asking you to identify the information regarding this graph. So I'm going to just go through it so you have all seen an example of this because you're going to see these on your quiz. Okay, if you take a look at the base of your exponent, so it's either growth or decay. Since the base is a fraction smaller than 1, it's going to be decay. So the basic parent function for this will look like this with a horizontal asymptote at 0, y equals 0. Okay, so this is your parent function, again, just so you get a sense of what it begins as. Okay, so what we're going to do is we're going to look at the shifting first. So we know that this horizontal asymptote gets shifted down 3. So your new horizontal asymptote is at y equals -3. So we're going down 3, which means the horizontal asymptote is y equals -3. Okay, we can also look at the horizontal shifting. The horizontal shifting that occurs is inside the function, so what value of x would give you a 0 in here? -1, so negative is to the left, 1. So this critical point right here is going to get shifted to the left 1 unit. Okay. Now we look to see, are there any, or we want to plot this critical point. Okay, so if we plot this critical point, we know we're going to use -1 as our x-coordinate, and let's find what the corresponding y is. So if x is -1, then we have a power of 0. 1/3 to the power of 0 has a value of 1, times 2 is 2, minus 3 is -1. So this point gets shifted to right here. Okay, then we look to see, is there any reflection here? No, no reflection. Okay, the shifting also takes into account the shrink or stretch effect. Since this value in front is greater than 1, is it going to be a shrinking or stretching effect? Stretches. Okay, and that's how we see it shifts down but gets stretched here. Okay, and so since there's no reflection, we know that this general form is going to hold true. So our graph is going to look like this, and at some point it's going to curve back around and come and approach this asymptote. What we don't know is where that y-intercept is, and so that's the main question is, how do you find the y-intercept? Here. The y-intercept is found by just plugging in 0 for x. Okay, so if we take this original expression and we plug in a 0 up here, so we get 2 times 1/3 to the power of 0 plus 1, and then minus 3. 0 plus 1 is 1, which just leaves the number itself, 1/3. Times 2 is 2/3, minus, if we were to express this 3 in terms of thirds, 3 is how many thirds? 9, right? 9 divided by 3 is 3. So if you look at it in this way, what you can see here is your y-intercept is going to be -7/3. Okay, now, is that consistent with what we see here? Okay, so -6/3 is right here, so it's a little bit beyond this. So right about there would be where it crosses. So it's still consistent with our sketch, and it should make sense that that would work. And now, just to finish out the way that this, or the other questions that you might be asked about this, is the left and right behavior. Okay, so left, it goes up or rises to the left. The behavior to the right, it does go down, okay, but it goes down limited. It only goes to this asymptote, so it is going to approach the asymptote. Okay, and then finally the domain and range for this. Okay, for all of these exponential functions, the domain is going to be all real numbers. There's not a case where you're excluding any value. So from -infinity to +infinity, that's the possible x values. There's no restriction on x's. The y's do have some limitations. In this case, remember the domain goes from left to right. The y's, the range goes from bottom up. So the lowest possible point is the point that approaches this asymptote. So -3, and extends all the way up to infinity. Neither one is included, and so it would be parentheses at both of those.